hummus is
It's chickpeas.
Usually the cherries, I feel like I use them orange on them.
Some are good for you. I think.
Trashy.
I saw the moon.
You saw the moon?
It was like behind you. What happened? A bit of work.
Scoot down a little further. No, that's all I want to do. Oh, talking to the morning class?
It's where like is that what I
You're stronger than her.
That's true.
I don't know. I'm working out a little bit.
Yeah, let's see some chest pump. No, it's a sign of one. Like Brian, he's not going to be able to. You this, Brian?
No.
You gotta work those babies up.
My eyes are up here. I'm more than just.
Very good.
That's good.
Somebody just checking out other guys' pecs.
I can't tell what I'm
My eyes
seeing.
are up here.
I can barely.
Oh no, what's happening? I don't. Holy
just
shit. What the heck? How do you even.
Oh, look at all
My
ruined.
boobs don't move like that, man.
We got the muscles.
I do work out. Yeah. I recently I did like 6 sets of pull-ups.
Hey guys, let's get started. So today I'm gonna do a couple of things. First, I'm gonna do a quick overview of Java, which I just posted an announcement on Canvas. I posted a short crash course on Java, assuming that you have some knowledge on OOP paradigm, right? Object-oriented programming paradigm, which is a prerequisite coming into this class, meaning that you have some knowledge in C++ or C# or any other OOP language, right? So in my opinion, once you have some basic understanding there, the transition to Java is very smooth. Java becomes so popular partly because it's very easy to pick up, right? The learning curve for Java is, in my opinion, probably the lowest among all object-oriented programming languages. So that being said, so I do not want to go over all the details in the short crash course I prepared, because this is not really a Java class. But I do want to highlight a few important notes from that, okay? Then once I finish that, I will spend another 5 minutes also to demonstrate how do you do your development for phase 2 in IDE, right? Which I assume you have experience, again, I assume you have experience with some IDE before, not necessarily for Java, but for C++ or Python or whatever, or Ruby, right? So at least you know what IDE is, okay? If you don't know what IDE is, hopefully you can use this as this course as a platform to learn that. But honestly, as a CS student, you all should have some experience with some IDE. And I'm gonna, in particular, demonstrate how to do that with Eclipse for Java. You will be surprised how easy it is to import the code and get it going in just 2-3 minutes, a few clicks. Okay? Looks like complicated, but easy. Okay. Then with those two covered, I will move on to the last part of SQL. We will be able to wrap up that, then move on to something new today, hopefully. Okay. That's kind of the roadmap for today. So with that being said, let's start with the first one, which is compressed course in Java. So this is an announcement I just posted. Okay, and you may find this particular file under Files, Lecture Slides, Java.pdf. Okay. Oh, by the way, I mentioned I made an announcement at the beginning of the semester. Everything I posted under Canvas is private material. Right? Do not post this anywhere. So I'm also the, I think I mentioned, I'm the chair of the Academic Honesty and Misconduct Committee for COE, College of Engineering. Recently, I helped 2 other faculty track down students who post their course material from Canvas to the website called Crack, like a textbook virtual website. Have you guys heard of it? Huh? Crack?
What's it called?
Crack. G-R-E.
Oh yeah, Greg.
Right. Yeah, is that what you call it? Anyway, there's this website for textbook rental, meaning that if textbook is too expensive, you don't want to buy it, you can rent textbook over there. And obviously, it allows registered users to post in addition textbook stuff, but also any other PDF files of that nature, right? So students from another class took the professor's homework assignment and solution, which professor explicitly said do not post anywhere outside Canvas. And he or she decided to post it over there. And this happened twice on 2 different courses. And the faculty decided to pursue this and fail the student for that. Okay. Of course, why I was involved, because the website protects the identity of the users. So I, as the chair of the Academic Misconduct Committee, has to step in and contact the company and ask them to reveal the user information of that registered user. Okay. So things do happen. Okay, do not take this, lightly. Okay.
So, is it correct to assume that they give you the information after you ask?
Yes, they do. Of course. Yeah, they do. Yes. It's like one of those CSI movies, right? No crime is without a trace, right? I'm a firm believer of that. Look at the Murder on the Oriental Express. Are you watching that movie? I was a fan of that movie when I was a little kid. Then the remake, I think the remake is not as good as the original one, by the way. But anyway, right? No crime is without a trace, and that's definitely true. Right? Especially when we talk about database, right? Everything is documented. It's a damn database. Right?
Yeah.
All right. So Java, what's the difference? By what's the difference, I mean, what's the difference between Java and another OOP language? First of all, there are no delete of object. Why no delete? Because Java has implemented, part of the reason why Java is so easy and so popular to use is because Java has implemented a mechanism called garbage collection. How many of you know what garbage collection is? In a nutshell, basically, Java free developers from managing your memory space yourself. Okay, we have the high-level overview is you have memory that's free for you to use. Whenever you initiate an object instance of some class in your code, it allocates a particular memory segment for that object, depending on the size of that object. The size of the object is determined by A, some metadata information about the object, B, the number of variables of that object. Okay, so that's how you determine the size of the object. You take the size of the object, you allocate that much memory from your memory space to that object. In most other object-oriented programming languages, like especially in the early days, like in C++, you need to manage those memory space yourself. Meaning that whenever you allocate an object, and you use this pointer to reference this object, to basically to find the content, to find out the content within the object, right? Now, everything is fine, but if you, for some reason, delete the pointer without deallocating the object, for example, so the pointer is gone. Now this object becomes a ghost floating around your memory space. Somebody else code might step into this memory space. Does that make sense? Right? That's one possible scenario. The other possible scenario is you keep your pointer, but you allocate the object. You deallocate the object, but you forgot to delete the pointer. Now somebody tried to use this pointer to trace this object will run into segmentation fault, meaning that you try to reference the content of the object. You thought it's still there, but it's no longer there. Okay? So that's segmentation fault. The first case scenario I talked about, when you delete the pointer, but you forgot to delete the object, somebody stepped into it, that can create a whole lot of security issues. Meaning that another person's program, so each program has its own heap space, right? But if you didn't manage your memory properly, somebody else's code can step into the heap space of your program, hence creating a security threat. So they create all these different troubles, right? So the designer of Java says, okay, let's get rid of all these problems once for all. What's the solution? Well, do not give any of this ability to the developers. I don't want you to manage memory space. The underlying Java runtime environment will manage the memory space themselves. Sounds like magic, right? Because think about it, it's not easy to do, right? How can the underlying runtime environment keep track of what object has been allocated, what object is no longer in use, blah, 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 and different programmers' code, it can be very, very different, right? It's not easy. Garbage collection is not easy. And especially you want to do it efficiently. A naive garbage collection is very easy, which is you do nothing, you only garbage collect when user program exit. That's obviously correct, but it's not going to be efficient. What if user program keeps running forever? Does that make sense? So it's all about designing an efficient garbage collection mechanism, which is not easy at all. So no delete, even though it's a single line, 2 words, but actually years of work to do no delete. It's not as easy as it may sound. Okay? No pointers, which goes back to the first one I talked about. Object-oriented programming the way it should be, meaning that inheritance, all that stuff is there. And platform independent. That's another key feature of Java. In C++ and many other programming language environments, you have a compiler that takes your code, which is basically a bunch of symbolics, right? After compilation, it becomes a bunch of symbolics in that programming language environment. It compiles those symbolic representation into native code on that machine, meaning that you look at the instruction set of that machine, and some symbolic keyword will be translated to a particular instruction on that instruction set. Does that make sense? IE is platform dependent. In particular, it's architecture dependent. If you're using an Intel processor, you're going to take those symbolic representation from your code and compile that into some particular Intel instructions called assembly language. Have you guys heard of assembly language? Have you programmed one?
Yes.
When I took a different route than a lot of people. When I first introduced to programming, my first language is assembly language. At the time of my age, which is kind of like dinosaur age, the most popular programming language is Pascal. I don't know whether you guys heard of it. It's still around, but I look at Pascal, the first program, Hello World, I said, that's easy, let's try some. But what happens to this program? Then somebody said, oh, it compiles to assembly language. Then I got curious and I went to study assembly language on my own. So assembly language meaning that you're using the instruction set in some hello, right? Basically, you're using some language to talk to the instruction set directly. You're manipulating those registers, okay, from your CPU in your cache directly. At the end of the day, all program basically boils down to that. But but obviously that's really hard because that's why we designed this high-level language that's more intuitive to human brain. Okay. But Java want to be platform independent, meaning that I write the code and I want to compile this once into a .class file, and I can take that .class file and run it on any platform, whether it's Windows or Unix, whether it's Intel processor or AMD processor or ARM chip. I want to be able to port my .class file rather than the source code and recompile them on each different platform. I want to avoid doing that. Okay? So Java managed to do that by compile your code. Obviously, if you compile your Java code into native instruction set, not going to work. It's not going to be platform independent. So they compile the Java code into something intermediate, into an intermediate layer in between the underlying architecture of your machine and the original high-level language, which is your program. Now something in between is called the bytecode. Then what they did is they designed Java runtime. Now this runtime obviously is dependent on different platforms, but that's abstract away from you guys, from the developers. The Java, those language developers who design the Java language itself come up with different runtime environments for different architecture and platforms. Then you have this bytecode running on top of that. So no matter which platform it runs, it exposes the same kind of quote-unquote API interface to your bytecode. So your Java code is compiled into a unified bytecode, which can then be executed on different Java runtime. That's how they managed to be platform independent. That being said, now here is my biggest dislike about Java. Because of those two reasons, garbage collection and the bytecode mechanism I just talked about, yes, it makes developer life much easier to write code, but obviously there's a trade-off. Trade-off is efficiency. You lose efficiency, obviously. I rather prefer to manage my memory space myself. If I know exactly what object I'm allocating, I can allocate it so that I can reclaim memory space right after an object is no longer in use. I can allocate an object only when I need it. Right? I can manage my memory space much more efficiently if you know what you're doing. But don't underestimate the difficulty when I say if you know what you're doing. I think 90% or 95% of people in this society, right, take it to any context, like driving your car, fix your house. People think they know what they're doing, but oftentimes they don't know what they're doing. This is including myself, right, under different contexts. So it's not easy to know what you're doing. In all cases, right, that's really the key, right? I mean, simple case, yes, you know you're doing, but complicated case, you think you know what you're doing, but you actually don't. So it's really hard to write efficient code. That's why Java still become popular. But my recommendation is, if you're gonna write low-level system infrastructure code, use C++. You get at least 6 times, maybe order of magnitude efficiency out of C++ than the same implementation of Java, assuming you are expert developer on both C++ and Java. Right? You know what you're doing. Code efficiency, C++ is always much better. Okay? But Java gives you all these benefits. Okay? The other thing is, in Java, in any object-oriented programming language, right, you have call by reference and call by values. Can someone tell me what's the difference of the two? Call by reference and call by values. When you make a function call, by the way, that's the context.
Call by reference passes a reference to the object.
Yes.
Call by value copies the object.
Excellent. Basically, look at the hand gesture I'm going to show you. Suppose this is the object, and this is the function. Function has its own heap space, right? So you are in this heap space, you are in another heap space, another function call, and you try to make a function call to another function, but this function needs the value, need to reference the content of this particular object. Call by reference says, when I make a function call to this function, when it needs to reference the content of this object, I will not pass this object to this function. Rather, I will pass the pointer to this function, make a copy of this pointer value, and pass a pointer value to this function. Now, inside this function, obviously, whenever I use this pointer to reference this object to make any change, this change is not only reflected within the function, but also is reflected within the object itself, because I'm using a pointer to the actual object. Does that make sense? You follow this? What about copy by value? Well, same scenario. You have the object. Instead of copy a pointer and pass a pointer value to the function, you make a copy of the object itself and pass this copy of the object to the function. Now, whenever this function makes changes to this object, what happens? It stays local. And the original object is not affected by whatever you do within the function. That's the difference. Very straightforward. Does that make sense? Okay? I think I have an example of that. Let me talk about this. So I have an example to demonstrate. Oh, you guys can say this? Oh. So I have a Java use one of this. So I'm not going to go to details. You guys can look at this example. And this simple code demonstrates the difference between call by reference and call by value. Okay. And standard input and output naming conventions, these are pretty standard. So static, final, and public. I think this is true for any OOP language, right? So I think I can skip this, and you can look at this yourself. In particular, static method means that it's a method shared across all objects of that class. You don't have to instantiate an object in order to call that method. You can just use the class name to reference that static object, static method. If it's non-static method, meaning that you can only call that method by first instantiating an object and use that object to call that function. That's the difference of static and public, private, and protected methods. A final basically means it's just a constant. And the inheritance mechanism in Java is implemented through two key features. One is called extend. You take a parent class and you take a children class to extend that class. For example, you have a parent class called car, then you can take a children class called sedan, extends car. Okay? That's when you use the keyword extend when the parent class is a real class. What if your parent class is quote-unquote abstraction, meaning that, for example, I have an abstract class called car, I define a bunch of methods, but I never really implement any of those. So that becomes an abstract class. In those cases, you do not use extend because nothing to extend is the abstraction, rather you use the keyword implements. And the abstract class in Java is called interface. So your children class will implement an interface, meaning an abstract class. But if it's a real class, your children class will extend that parent class. So that's the two ways you can do inheritance in Java. Okay? What else I'd like to cover? Exception handling. This is fairly important. In Java, any single class will be able to throw, in fact, I think every class will potentially throw an exception, right? Meaning that, for example, the simplest exception all of you might have made this mistake when you first start programming is array index auto boundary, right? Your array has 10 elements, but you're trying to reference the 11th element in your code, obviously. Right? Obviously, it's going to go wrong, right? So that's called an exception in Java. So the simple mechanism in Java to handle exception is called try and catch block. You run your code, the segment of code that potentially can throw an exception in what we call a try block. Then at the end of that try block, you catch exception. There are two ways to catch an exception, by the way. One is to catch exception-specific exception, meaning that you know exactly what type of exception this segment of code may throw, then you look for those specific exceptions. In this case, for example, index auto bound. Why? Because I'm referencing array elements in my code, so I know that's the specific type of exception that may be thrown. But what if you run a bunch of code? Two cases. One is they throw a bunch of different exceptions. If you try to catch each one of them, your code becomes really difficult to write. Secondly, you don't even know what kind of exception it may throw. For example, you call somebody else's class, you didn't implement that, it's not a standard Java class, you don't know what exception it potentially can throw. What do you do in that case? Well, all exceptions in Java are extended from this root parent class called exception. So, what do? You just catch exception, that's it. Ignore the specific exception that segment of code may throw. Just catch the parent of all of them. Okay? So that's typically what I do. When I do a demo code, when I work on production system, no, do not do that. Right? But when you do a core project like what we're doing, catch all. That's it. Then you can, each exception object will encapsulate the content of the stack. What's stack, by the way? You know, whenever you make inside a class, whenever you make a function call, it allocates a stack on top of another stack, on top of another stack. So exception capture the trace of all the stacks. accumulated in your code. So you can print out the stack trace, meaning that what? The lineage of how you reach here. Does that make sense? I hope it does make sense. You know the word lineage, right? Like, how do I get to here? I was in my office 10 minutes ago. Before that, I was in a lecture hall. Before that, you can trace all the way back to the time I was born. Does that make sense? That's called stack trace. Okay? Like, me coming here from the office is like making a function called teach you damn class. Right? That's like allocating a stack on top of your heap. That's what's going on. That's it. I think that's all I want to cover. I mean, there's a specific example you can run over yourself, but I don't think I want to go into that. Okay? Oh, but last thing is Java. I do want to talk about something called packages. Okay, this is the last thing I want to talk about. So Java, so in C++, you have something called STL. How many of you heard STL? How many of you know what STL stands for?
Standard library.
You ignore the letter T, right?
Standard template library.
Yeah, standard template library. What it does is nothing, it's a fancy name, but what it does is somebody is nice enough to write a bunch of common utility classes and package them into a library using something called template, and that's why it's called standard template library. Okay? Java has something similar to that. Java organizes everything into something what we call packages. So meaning that classes that achieve similar functionality are grouped together into a package. For example, you have I/O class, meaning all the classes dealing with I/O input and output, that's packaged into some I/O packages. Right? All the classes deal with database connection, packaged into a connection package, right? Things like that. So that's the concept of packages. In Java, the only thing you need to know is once you have a package name on disk, on your physical disk, you have to make sure all the classes from the packages, from the same package, must be contained in a folder with the same name as the name of that package. That's what you need to know. Okay, suppose you have a package called Uber. Then physically on your disk, all the classes under the package must be contained in a folder called Uber. The folder name and package name must match exactly. Okay, that's what you need to know. Okay? All right. Then, one last thing is, once you have this nicely encapsulated concept called package, then others can import a particular class from your package or import the entire package once for all. For example, I can import java.io.heuristic to make every class within the I/O package exposable to my code, meaning my code can call any class from the I/O package now. Does that make sense? This is similar to the concept of linking in C++. Or in C, right? You want to go out with that. All right, I think. There's a bunch of other stuff I leave for you to explore yourself. Look at this crash course. I mean, even if you think you know Java, I think this particular 30-page-ish slide is useful as a review to kind of highlight some of the fundamental subtle points in Java, right? For you to kind of recap. Okay, any question on that? Good. Now once you understand package and all that stuff, so Java make a really nice online GUI for you to explore different packages. Okay, I posted the link. So this is all the packages you have, right? And these are all the classes from different packages. If you click on a particular so for example, if you look at the connection class, class. So this basically tells you what this connection does. For example, establish a ODBC connection. When you talk about Java, I already explained what ODBC is, right? In the context of Java, this becomes JDBC, right? But you need a driver for a particular database window, which we distributed to you for MySQL, right? So this tells you what this does and what are the member variables, what are the methods, and what each method does. So it's a really nice way to explore a particular class and the package, the tree of this package. All right, that's that. Now, next thing I'm going to show you is how do we do our phase 2 in IDE. So you download this thing called Eclipse. Eclipse has two things related with Java. One is Java EE. One is standard Java IDE. For phase 2, you want to download standard Java IDE, not Java EE. Java EE is for web development, which you may need for phase 3, but not phase 2. Okay? So you download that. You extract the zip file. There's nothing to install. Because why? Because, as I explained, Java is platform independent. The entire IDE Eclipse itself is written in Java. So when you download this, they actually download the Java runtime environment for you automatically as well. So by the time you finish downloading this, there's nothing to install. You click, it will invoke the Java runtime environment, come with the package itself, and execute this Eclipse Java program for you. Okay, so really nothing to install. So you download, you unzip, that's it. Then you click on this icon. It asks you to supply a workspace folder. You can choose the default. You can change to a different location if you want to. Just take the default. All right, so that's the interface. Now, what you do is obviously, the first thing you do is new a Java project, give a name for it, like Uber. We call it Uber, right? So Uber, that's it. Finish. Okay, that's how easy to create a project, right? Now, once you have a project, what do you do? Then there's a folder called SRC. That's where your source code will go to. And first thing first, we want to create a package, right? If you look at my distribution, I have a package called CS5530. Of course, you don't have to name your package that way, but let's be consistent with my example, right? Let's say I want to create a package called CS5530. So right-click on this, new package. Finish. So now you have a package. Now inside the package, you want to get your source code, right? You can copy-paste each code individually, or you can use something called import, right? Let's do the import. That's much easier. To import a bunch of Java code into this package. So I will just click on this and run import. Now I have downloaded the file I distributed to you guys to my local file system. So I'm just gonna import from my file system and browse to that folder and select those Java code and import them into my package. So select file system. Then I browse through the location of that file, which is under my job box, teaching, projects, phase 2 example, inside the folder CS5530. Okay, so I select that folder. Now it shows the source code in that folder. You want to import only the Java code, not the .class file. Those are the compiled version of those Java code. By the way, because of the stuff I mentioned earlier, which is Java compiled into bytecode, right? It's actually very easy to do reverse engineering of Java code. If I give you a .class file, and if you understand how Java runtime environment works, you can write something similar to the Java runtime environment to understand every single bit of that bytecode. Meaning that you can reverse engineer to get the source code very easily, no matter how complex the package is. You know, when I was an undergrad, I reverse engineered a Java software with like close to maybe thousands of class files. in just a matter of minutes. Very easy to do. But for C++, that's really hard. If I don't give you a source code, why? Because C++ compile into architecture-specific assembly language code. And that's really, really hard to reverse engineer. Okay? So in other words, if you want to protect your code, and if you distribute to others the binaries, the compile version of your code, if you want to do that with Java, good luck. You will always fail. Okay? Okay? If your code works, if you think your code worth something, do not write it in Java and distribute the binary code as well. Okay? Okay, now let's import this code. I'm gonna select this connector. I'm gonna ignore connector2.java simply because that's the connector with SSH connection, and I didn't supply the username and password in that, so it will, if you try to compile that, it will run into errors. So I just use the direct connection. Course, order, test driver 2. That's it. That make sense? Finish. Now you got a bunch of code in your package. That make sense? One last step before you run this code. As I mentioned, this code depends on some external jars. In particular, you need a MySQL jar to make a JDBC connection to the MySQL database server. So you need to somehow, in the command line interface, we tell the underlying runtime environment, I need this jar by using the -cp, -class path. Right? I demonstrate that. Do you follow that? Do you remember that? So how do we do this here? Well, you click on the project, go to property, then there's something called Java view path. Then there's the panel called libraries. You add an external jar. You know, browse to that folder with a jar, you select a jar. You can select multiple jars. The other jar is for making a SSH connection. Since we don't need that right now, so I didn't import that jar. But if you're gonna make a SS connection, you need that second jar file as well. You can, of course, import multiple jars. Apply and close. Now you have a reference library link with MySQL jar. Now you just run test driver 2. Got it. That's it. That make sense? Okay. To convince you that this works, okay. So you can get it running here in IDE. Any question on these simple steps? Few mouse click, you're there. The nice thing about using IDE is it gives you all these nice features, such as, so you can terminate running this, just exit the code. Give you all these nice things of, for example, if I close this, it gives you all this automatic completion and explanation what each method does, which is nice. But oftentimes I find this is like overwhelming, right? I just prefer to code in Vim or Emacs, to be honest. But if you guys like this, go ahead with this. Okay. That make sense? Any question on this? Yes. By the way, one last before I answer your question. Eclipse, as I mentioned, is a Java program itself, and it comes with the Java runtime environment. What does it mean? That means you can download this to any platform that you choose. You can download this to Unix, you can download this to Mac, you can download this to Windows, you can download this to even Android, if you want to, right? And you don't have to install anything, you can just get it running. Because it comes with the Java runtime environment itself, and itself is just a Java program. With that being said, take the question. Yeah.
So, if we get this up and running, is there any need to keep or use the SQL bench software?
No, SQL bench is just a program somebody has written that allow you to connect to the database SQL standard, and nothing to do with our system.
Is there a version of Eclipse that we need?
I would recommend, I think I posted a link.
Yeah, you posted.
I posted a link, but if you just Google your friend, right? Somebody joked to me, computer science nowadays reduced to Google plus OpenStack. What's the name? Stack Overflow. If you know how to use Google and Stack Overflow, you are pretty much 50% to be a decent programmer. Okay. So you Google this, click on this. As I mentioned, there's Java EE, which is not needed for phase 2, which is for web programming. So you go with Java IDE. And it will, nowadays this website is super sophisticated. They detect your operating system automatically and give you the web version to download. And this is already Windows, you just choose 32 of 64 bit. Download, it's a zip file, unzip, that's it. All right. Okay, fantastic. Now, with that being said, you guys should get your feet on the ground. Get your feet on the ground and start working on your phase 2. Right? There is no more excuse left not to execute. Now it's on your hand. Okay? You need to go up your sleeve and get things going. Okay? Does that make sense? Cool. All right. I'm going to continue the discussion on MySQL. Oh, sorry, not MySQL, SQL. So we talked about the concept of views. So to quickly recap, view is nothing else but abstraction you want to expose, right? Abstract meaning that it's not a physical table in the database, but you query this guy so much, and you want to create an abstraction so that others can issue a query against this abstraction rather than some base tables in your database. That's the concept of view. I demonstrate this using a specific example called reps, right? Red color number reservation on red color boat. Go ahead.
Do you use views to create update transactions in the database, or are they just read-only abstractions?
Good question. I'm going to come to that actually in a minute. So you talk about the concept of transactions, which I don't want to go into because we haven't even talked about transactions. But I do want to have a discussion on update on views at the time being. We can talk about the connection with transactions when we have finished the discussion on that. Sounds fair?
Okay.
Okay. Now, as he pointed out, view is abstraction, right? Meaning that by default, this view is just some abstract concept with no data in it. Just like I talked about in last lecture, when you define a view like red, meaning showing the number of reservations on each red color boat, and when somebody issue a query against this red, what happened? What happened is the underlying system will simply replace the reference to this view, meaning red, with the definition of view, and making this query into a nested SQL block. In the default case, that's what happened. Does it make sense? Yes? So far, so good? But obviously, if you run this all the time, it's not very efficient. You end up introducing nested queries all over the place. A more efficient solution is what? Is once somebody defines a view, I can quote-unquote materialize that view. Materialize meaning that I populate data into that view. With respect to the snapshot of your database as a time instance, the view is created. So using this example, res is no longer just an abstraction, but with real data in it. Meaning for each red color boat ID, how many reservations I have on that red color boat. Now, with that being said, when I write a query like this, when I write a query like this, I no longer need to substitute the definition of view using that complex block on top and making this a nested query. Rather, this is simply treated as a table with real data in it. Of course, it's much more efficient. Does that make sense? But there's no free lunch. Right? Remember that. In your life, when somebody offers you a deal that's too good to be true, don't take it. Oftentimes, not oftentimes, 100%. So far in my life, 100% time is something wrong with it. I learned my lessons, and I will not make the same mistake again. I mean, it's fine to make mistakes, but shame on you to make the same mistake twice. totally fine to make stupid mistakes. We are human beings, people always do, but shame on you to make the same mistake twice, right? So what's the catch? Can someone tell me what's the catch?
If you update one of the tables that view is referencing, it has to go back and update.
Exactly. If you update either the boats or the reserve table, you need to check whether that potentially impacts the content of that materialized view. And this can be expensive because how do I know whether a particular update to boats or a reserve will impact my view or not? I don't know. I have to check for every single update that happen in boats or reserve. And if you materialize your view, all the views you have in your database, you end up doing this check all the time. Does that make sense? Yes? So which creates a lot of burden on the underlying database engine. So obviously there's a trade-off, which is when do you materialize the view and when do you not materialize the view? And some simple naive strategy is as follows, right? If you observe that there are very few updates to the tables affecting the views, then you should materialize the view. But if you have frequent updates to the tables referencing the view, you should not materialize the view. But how do I know this? And update patterns of a table change over time. Like taking student table as an example, you have a lot of updates at the beginning of a semester, like when new student register, then in the middle of the semester, nothing happens. But it's not like we kick off student every day from university, right? Or it's not like we take new student every day for university. So during the middle of semester, nothing happens. At the end of semester, again, you see a lot of updates. So simply looking at update patterns may not be a good enough indicator, right? Because it really depends on what time you look at it. And an even better strategy is a hybrid strategy. I look at my definition of views, for example, taking this reg as an example. I noticed that, for example, just for the argument's sake, all the boat ID with less than 200 value, meaning the boat ID is less than 200, nobody reserves those boats for whatever reason. For some reason, this club, people are obsessed with boats with a boat ID greater than 200. For whatever reason, who knows? So the number of reservation on boats with ID less than 200 stay roughly a constant. But number of reservation for boats with ID greater than 200 change all the time. If you have that knowledge, what should you do? Well, you should partially materialize your view. Partially materialize your view. Do you follow that? How do you figure out all this automatically? It's not easy, right? You use some combination of machine learning and system techniques to do this automatically with minimum human intervention. That's kind of what people do, right? I don't want to go into the details of that, but for the purpose of this class, you can just think about view as an abstract concept without being materialized. Okay? So views serve really two purposes. One is to simplify your query writing, as I demonstrated already in that example, right? But view actually has a bigger mission to accomplish. The bigger mission, or the more important mission for views, is for security reasons. In particular, something called access control. Access control in database is super, super important, right? Who can access what data? Because database stores sensitive data. Bank accounts, national security database, bunch of stuff. Like even student score database, that's important, right? You don't want somebody to be able to hack into a student database and change the score of a particular student, right? So who can access what is really, really important. How do you control that in a database setting? And this is called discretionary access control. In particular, database engines achieve this using a keyword called grant. So in particular, the format, the syntax is as follows, like I show on the top, right? The privileges can be one of the followings: select, insert, delete, references, or all. All basically means you can do everything. Select basically means, on the other hand, means that read-only access. You can only do selection, nothing else. On an object to user, let's ignore with ground option and end, which is in a square bracket. In regular expression, as I mentioned multiple times by now, that square bracket means that's optional, meaning you do not have to initiate this statement with ground option, but you can if you want to, right? So let's ignore that for now. What does it mean? For example, what if I do grant select CS5530DB to 5530 user. What does it mean? That basically means I'm giving read-only access to this database, CS5530DB, to this particular user account called 5530 user. That's how, for example, I control access to the class-wide database, and I'm able to share one account with all of you without worrying about some of you trying to hack and manipulate the underlying database, because all of you share that account with read-only access. Does that make sense? Yes? But what about you purge that database for phase 2, which I cannot just give you select-only access, right? If I do that, you can do nothing for your phase 2. You cannot even create a table. So for that, I will create a separate user, and I will say grant all everything on, for example, 5530DB01, the first database, to 5530U01, to user 01, so that user 01 has full access to DB01, to the first database. I do this for all different teams. Of course, I run this in the script. I don't type this manually, obviously. That make sense? Yeah? In fact, I can show you that. Can I show this? If I show this, it has password embedded in it. And it's fine. I assume you guys already. Oops. Okay. Right. So let me go all the way down so you don't see the password. The last one, I think nobody is using it. Right? Oh, you cannot even see it. Perfect. Even better. Okay, let me change a different program to say this. Because Vim uses a particular color scheme. That's a bad combination when it's under flashlight like this. So let me use just Vim, VI instead of Vim. Right? So that's what I do. I write a script to do this. Does that make sense? Yeah? For each user, actually, I have to do this statement twice. That's because I have to give the access to this user when this user logs in locally, meaning on Georgia server, if you're using an SSH connection to the Georgia server, or you log in remotely, which is a second block identified by %. % means any URL. You're logging from any URL, remote locations. That happens if you are on a campus network, you're making a direct connection, or you're on your home network, you're making a connection via VPN. That make sense? That's why I need to do this twice. All right. So that's that. So now you may wonder, okay, fantastic. What's the connection to Vue anyway? We talk about all this access control stuff, but why it has to do anything with the concept of Vue? Well, it all goes to what can be that object. So far in my example, I use a database as an object. But who says I have to limit myself to database as an object? In fact, you can use a table as an object, and you can use a view as an object. Now this becomes really useful. The last statement is the key, right? That becomes really useful because a table, if you think about it, is a finer granularity than a database, but maybe it's not finer enough. Give you an example. For example, I have a student table, and I have student advisors. Let's say I have a student table for all students from the university. However, I want to do the following. I say an advisor from CS department can only look at CS student record. An advisor from the math department can only look at mathematics students. But I cannot grant select on students to any of these advisors. That means he or she can look at all student records. In that case, I'm relying on people's good conscience that he or she will not look at other records. Does that make sense? That's another lesson I learned from my 30+ years of life. Do not rely on people's conscience. It doesn't work. I'm sad to say this, but that's the reality. Okay, that's the reality. Does that make sense? I mean, maybe I'm too pessimistic on this. You can have a different. I mean, I'm not trying to convince you to agree with me on this, by the way. If you have a different view, totally fine. But obviously, database people share the same view with me, right? They do not rely on consciousness to do this. So they say, okay, I cannot grant access to the student table for each of the advisor. What are your choices? Choice number one, split the student table into multiple sub-student tables, right? You have a CS student table, you have a math student table, blah, blah, blah. Does that make sense? Works, but it's like a hack, right? Instead of dealing with one table, now I'm dealing with, if I have 150 departments on this campus, I'm dealing with 150 student tables. And imagine there's a super advisor at the university level who can see everything. For her or for him, that becomes a super challenging task. Instead of looking at just one table, this person needs to look at 150 tables. So what's a better solution? Well, you create a view. You create a view called CS student, you create a view called math student, then you grant, select, or all privilege on that CS view, CS student view to the CS advisor. Grant all privilege on the math student view to the math advisor. Do you follow me? So this view is a subset of your student table, right? So it gives you a finer granularity. You can go even beyond that. Who says your view can only select a subset of rows? Your view can select not only a subset of rows, but a subset of columns. Right? You can use projection in the definition of view. So if you combine all this together, you can narrow down to a single cell. For example, Feifei's salary. I define a view like that. That's a single value in my database. Make sense? And if I'm the database administrator, I will say grant all to Feifei on this and nothing to everybody else. Does that make sense? You don't follow me? I have all access to this single value. Nobody else can even read this value. I can do whatever I want. Of course, trust me, I'm a good guy. I will not manipulate my salary data. Good luck with that when you present this case to the president of this university. Not many people follow my joke. Anyway, it's not a good joke. But you see the point, right? With view, you can define a really fine granularity all the way down to a single value of your database. If you want to, right? If you want to. So that's the purpose of view. Okay. Now, there are two more important topics. I think I kind of talk about the second topic, which is SQL embedding in other language, which I distribute the code to you already. So I'm going to focus on the first part, and I will spend another 5 minutes to recap some of the important things about SQL embedding in another language. That will wrap up everything we need to know about SQL. Next lecture, we'll start something completely new, nothing to do with SQL. So we're going to talk about constraint. Constraint is such an important topic that has surfaced many, many times by now, right? Like, we have primary key, foreign key constraints. We have total participation constraints. Some of those are easy to deal with. For example, to indicate a primary key or foreign key constraint or candidate key constraint, you simply use a keyword called this is the primary key or this is unique for candidate key. And referentially, you have this reference is another table to indicate a foreign key constraint. Those are easy to deal with. And another easy case is like total participation constraint, right? Every department must have a manager and only one manager. What do? You take the employee ID, you take that as a foreign key and introduce that into the department table and make sure it's not null. Meaning that whenever you insert a new department record, you need to specify an employee ID value as the manager of that department. Does that make sense? But that's if you have something like this. That's if you have total participation constraint. You see managers, right? And a person can be a manager of multiple, potentially, let's say a person can be a manager of multiple departments, but each department should have what? Just one manager. What is that? Can someone tell me? Is one to many or many to one?
One to many.
Right. And let's say each department must have a manager, which indicates that this is both. Right? That's essentially what you have. Do you follow this? Now, let's assume I have SSN. And of course, there are a bunch of other attributes. I don't really care. When you convert this to tables, what happens? You have an employee table with SSN, which is the key, and a bunch of other attributes. You convert this to a department table with EID, a bunch of other attributes, and you take SSN as a foreign key references employee. Right? But how do you capture this? The fact that every department must have a manager? How do you capture that? You say, not excellent. That's what we learned how to do so far, right? Now, look at this. Assuming I change this to this. Now, what does this mean now? Can someone tell me?
You don't have to specify not null.
Oh, you're talking about the technicality of how to do it.
Right.
Semantically, what does it mean? Huh?
Never mind.
No, you can go ahead and try to answer that. Do you know the answer?
No.
Okay. Over there.
Full participation.
Can you be a little bit louder?
Full participation.
Okay, yes. So he went to the specific technicality. You give me a syntactic meaning of that, which is, yes, it's total participation. But semantically, what does it mean? Something in the middle of what two of you just said.
Let's combine.
Meaning that full participation and now. Semantically, what does it mean? Can someone tell me? Every employee must be a manager. So not only every department has at least one manager, and every employee of this organization is a manager. And this probably is the organization you want to work for, right? Because if everybody is a manager, nobody does the work. Right? So, but let's say that's the corporation that we have. How do you capture this in your design? So now we go to the technicality, which is what you proposed. You said SSN no. Right? That's what you proposed, right? Is that right? You add this to this table. Does it work? The answer is no, right? In fact, you don't even have to add this because SSN is the primary key of this table. Being a primary key means that you cannot be null to begin with. And null simply means you need to specify an SSN value for each employee record. Fine, I do that. But how does they imply that this employee must be a manager? No, not at all. Do you follow this? Yes? And note now on this side doesn't capture this as well because it simply says for every department I need to specify an SSN value, but it doesn't say that every SSN value from the employee table will appear for at least one department. So how do you capture this? With the stuff we learned so far, no, you cannot capture this. And that's why for phase one, I bold in the project specification, we don't want you to worry about constraint checking in phase one because you haven't learned enough to cover that. You follow that? Now let's look at how do we do this in database. Okay? So review, I'm gonna skip this. So let's start with some simple ones. Simple one is what we call table constraint. Remember the discussion of create table. Create table, at the end of create table, you can supply something called table constraint. And a constraint is always expressed as a Boolean statement. As a Boolean statement, meaning that it evaluates either true or false. Okay? A constraint is always a Boolean statement that evaluates either true or false. So in this case, let's say I want to make sure the rating values, even though, if I don't have that check, which defines the constraint, by the way, at the end of the table, let's imagine we ignore that. then all I have is a domain constraint on the rating attribute, which is an integer, which basically says rating can take any value as long as it's an integer, which is fine, but not good enough if I want to limit my rating choices to 1 to 10. Does that make sense? So how do you do that? Well, you supply a table constraint called check, bracket as a set. Any constraint must be a Boolean statement. In this case, it's a Boolean statement involving one of your attributes from this table, which is rating greater or equal than 1 and less than or equal to 10. What will happen is now if somebody tries to modify this table, modify means that either insert or update. I will check the values of those affected records on the rating attribute. If the value of that rating attribute of those affected records make the evaluation of this Boolean statement to true, then that's allowed. Otherwise, it will be rejected. So that's how we check constraint. Does that make sense? So this is a single table constraint. But sometimes you can get, as being a Boolean statement means that you actually can be really sophisticated about it. Meaning that you can even define your Boolean statement using an SQL block. For example, you want to make sure for your reservation table, there's no reservation on boat called interlink. Why? I don't know, some VIP reserved interlink. Right? Ahead of you. So nobody, and tell the club owner, nobody should make a reservation on interlink. Okay? How do you do that? How do you do that? Well, you select imagine you are in the reserved table, right? It's a table constraint attached to the reserved table. So what you're saying is for any reservation record, I have a boat ID. This boat ID references the current reservation record you are checking. You are checking. You say, okay, this boat ID, I probe into the boat table using this boat ID. I find the name of that boat. And this returns, by the way, a single value. Why is that? Why this block return a single value? Why this block returns just a single value? Because boat ID is the primary key of the boat. So this is a single string value. Then I say this must not equal to interlink. Check. That's it. Now, if somebody make a reservation with the boat ID equal to some boat named interlink, this statement equal to what? Equal to false, which means that reservation will be rejected. You follow this? So this is some simple cases, right? Let's look at some complicated cases. Let's say number of boats plus number of sailors is less than 100. I mean, it's a weird constraint, but let's say we have this constraint. It's a really weird constraint. I don't know why you wanted this, but let's say we want to have this anyway. So what you say is, continue the pattern we have. You say, okay, I can do this using a constraint like this. I select from sailors, I create table sailors and I check, select count from sailors plus select count from boats less than 100. Again, pay attention that that statement after the check keyword must be a Boolean statement. Must be a well-formed and properly formed Boolean statement. You follow this? It looks fun on surface, but in reality this doesn't work. Why? This is because a constraint is only checked. A constraint is only checked. A table constraint, to be more specific. A table constraint is only checked if that table, the attached table, is being modified. That being said, can someone tell me what's wrong with this definition? Go ahead.
It's because it doesn't work with the boat table?
Yeah. Following what I just said, a constraint is only checked when the attached table is being modified, meaning that the underlying database engine will only check this constraint when sailors table is being modified. But what if somebody keeps inserting both to the both table? constraint is never checked because you define this as a table constraint attached to the sailor's table. So I can easily exceed this constraint without you being notified at all. That make sense? That's the problem. So how do you fix it? You may wonder, okay, why the earlier case works? Well, that's because you don't care if somebody modified both tables. You only care if somebody make a reservation on some boat named Interlake. So this, even though reference both table, but actually you only need to check this when somebody modifies the reserve table. Making changes to the both table will not affect this at all. Does that make sense? Of course, there's one assumption when I say that. One assumption there is you do not modify the boat ID value on the boat table, and you do not modify, for example, the name of the boat. If somebody is allowed to modify the name of the boat, this will fail as well. Why? Because a boat ID 111 could be named something else, and you allow a reservation to be made on it, and later on somebody changed boat 111 to name Internet. So this only works if you know nobody gonna modify the name of the boat nor the boat ID value of the boat.
So you have to create the constraint on the boat table as well.
How do you fix this? I'm gonna talk about that next. Okay. Now, how do we fix this? Well, you use something called assertion. That's not a table constraint, meaning that it's not attached to any one single table. It's an object stand by itself. So you say create assertion with a name, then you check this. Now with this being defined, the underlying database engine will look at the construction of this and figure out what tables are going to affect this assertion and monitor updates to both tables. Okay, so that's one way of doing it. Now that being said, let's look at how we solve this. How we define a constraint that every employee must be a manager. How do we check this?
Would you look at the number of unique manager IDs in the departments and make sure it's equal to the number of employees?
Yes, that's one way of doing it. The unique number of managers here must equal to the number of employees, number of SSN values you have here. That's one way of doing it. Do you follow this logic? The unique number of SSN values from the department table must equal to what? The number of employees you have from the employee table. That's one way of doing it. Do you follow this? What's another way of doing this? Make sure every employee is a manager in the department, in the department table. Well, you can define. So what you do is you can do a join of the two. That make sense? In fact, you can do auto join of the two. You can do auto join of the two. And select those with DID equal to none. That means that employee is not a manager of a particular department. You do a left auto join between employee and department. And you put out DID. If there's any null value in your output, you find at least one employee who is not manager of any department. Does that make sense? And you say that must be null. You check. Right? For example, select count from what I said just now. Here, what you do is do a left auto join for those DID equal to none. And this count must equal to none, equal to 0. Does that make sense? You follow this? Okay, you select DID from E left auto join D on SSN where the ID, put it down. That's it. Do you follow what I'm doing here? Okay. I have some more examples. No sailor should be allowed to reserve more than 5 different blue color boats. How do I do this? Well, you say you do a join between reserve and boat ID and make sure color equal to, oh, I said red. Okay, change this to blue. Okay, change this to blue. And group by sailor ID and having count greater than 5. What you're trying to do is find sailors who have reserved more than 5 blue color boats. And this result set must be not in this, in order for this assertion to be true. That make sense? Okay? Okay, so that's assertion. Now I'm gonna talk about trigger. Assertion is, by the way, in most commercial database engines, they slowly, one by one, drop the support for assertion. They drop the support for assertion. For a couple of reasons I will talk about after we talk about trigger. Okay? Why? Because they find trigger is much more flexible, much more powerful way of doing the same. In sports, everybody starts supporting trigger and drops the support for assertion. A lot of these engines actually has the support for assertion, but by default they disable the check. Why they disable the check? The reason is for efficiency consideration, right? Assertion, as you can tell, is going to be super expensive to check. Because whenever the underlying table, one of the underlying table is being affected, you need to check assertion. This can be really expensive if you have update-intensive workloads. Does that make sense? So people introduce something called trigger. Trigger has 4 components. Has something called an event, has a condition, and has an action. What happens is that you're telling the database to monitor this particular event. And when that event happens, you check that condition you specify. If the condition is true, you take the action. If the condition is false, you do nothing. So that's kind of the general overview of trigger. Let's look at a specific example. Now, the real difference between assertion and trigger is really the event and condition. With event and condition, you can specify much more flexible ways of checking constraint, rather than just saying, oh, whenever this table is modified, you need to check this assertion, right? So in particular, events can be before, after insert, after delete on table, or on a view, by the way. For example, before insert on professor, or after insert on professor. Okay? So for example, I want to make sure, let's say I have a professor table as simple as that. I want to ensure that any new professor inserted has a salary greater or equal than $60,000, which is the bare minimum you should pay a professor. Huh? In my opinion, you should pay much higher than this. Right? For example, I would not work for a university who has something like this. I will be honest about it. Okay? But let's say I have this, and I want to make sure that, okay, not only you want to make sure his or her salary is at least $60,000, and it happens before you hire him, offer. Don't make it after the fact. Something negotiate with you. Take this as a negotiation strategy. Let's do this first, then we fix later. No. Fix this first, then we do this. So before insert, that's what before insert and after insert. Do you follow what I'm saying? So in this case, I will write a simple trigger as follows. By the way, what I said, stay in this classroom. Don't take my video and go to the president and show, oh, Faith is at this. Actually, I don't care, but if you're nice, you don't do it. So you create a trigger, you say minimum salary, and you say before insert, meaning that, oh, fix this, or we don't hire this guy. Don't hire this guy, then fix it later. So before insert on professor, that's my event. And what's the condition? Then you say for each row, I check if new salary less than 60,000, then I read an arrow. By the way, the specific syntax of this, if and else, is database specific. meaning Oracle, MySQL, PostgreSQL, SQL Server, they all have different syntax for this language, but in general, people follow something called, you can Google this, PL/SQL. PL stands for procedure language, SQL is structured query language, meaning that you combine some high-level language features such as if, else, while loop, for loop with SQL. That's called procedure language, not programming language. Procedure language because it's like a procedure. PL/SQL. They all follow similar syntax. I'll give you something like this. In this example, this reference this newly inserted reference. Okay, there are more to triggers, as you can tell. With trigger, you can do even more sophisticated things. For example, you can even say, instead of with application error, you can say send an email to somebody. You can write a code, C++ or Python or whatever code, and the action can be a call to that code. The trigger can be really, really powerful. Does that make sense? And it's more efficient than assertion. I don't know whether you guys see this, because, for example, now you can check only before or after or whatever, right? You can, rather than a generic statement like, once this is updated, you need to do something. But here you can be a little bit more specific on what condition will trigger. That's why it's called trigger the check. So it's more efficient. Does that make sense? Question?
So if it's raising an error, does it automatically know not to add the entry?
Well, when you raise an error, in this case, it will prevent the database from adding that record unless the database administrator come in and do something about it. So with that being said, I think time is up. But before I let you go, I will define our trigger next time. After 50 said done, we can start packing. Right? Just define our trigger like that. So I want to make a couple announcements. One is we now cover everything we need to know for homework 3. Homework 3 problem 2 asks you to write a bunch of constraint checkings. For that, you can use either trigger or assertion, but I will recommend using assertion. Okay, I will highly recommend using assertion. And that, we have a lot of slides on trigger, but as far as trigger is concerned, this is as far as I will go. And I will encourage you to look at those additional discussion on trigger yourself. And there are some slides on doing SQL in the embedded language environment, which I talked about already. But if you want to have a few slides as a reference, you should continue with these slides. At the end of it, I have a discussion on connection, statement, result set, cursors, and all that stuff. Coming back on Monday, I will not spend any time on SQL. I will move on to something new. So do make sure you go over the remaining part of this slide yourself. With that being said, I'll see you on Monday. Hey, you are.